Right, this is the second video of 2 for systems of conics. In this one, we were doing graphically again, and then we will do algebraically using elimination this time. So first thing, obviously, we have to solve both equations for y. Because we get technically four equations with a plus or minus, I'm definitely going to use the plus or minus tool. Okay, so if I solve both of these, I'm going to just skip to the end result. We get plus or minus the square root of 81 minus 9x squared plus 72x over 25. And then y is plus, or this one's a little easier, 9 minus 9x squared over 15. Okay, so I will type both of those in the calculator. This is going to be a little challenging to do the intersection points, so you'll have to pay attention to how you have to be careful. So I cleared out my y1 and my y2. I'm going to do second parentheses for the bracket, -1, 1. Second bracket again. And since these are pretty substantial square roots, it's definitely helpful to type it in one time. I'm going to do alpha y equals. Another option for this one, I will show an option for the older version of the calculator since I know there's a few people out there that have that. And you can just use parentheses instead. It's not terrible to do. Oops. A little overzealous with the 2's there. Okay, so we have that equation, 81 minus 9x squared plus 72x over 25. And then again, I will do second parentheses, -1, 1. And then I will do the square root. This time I'll use parentheses for the numerator, but you can do alpha y equals again if you would like. And then I'll hit divided by -15. There's only one thing on the denominator, so that technique works fine too. And you can use that instead for the top equation if you don't have the option of setting up the fraction. Okay, I'm going to hit graph, hoping that this whole thing shows up on the screen I previously used, which was the -5 to 5. If it doesn't, we can stretch it a little bit. It looks like we have to make it go a little bit further, which is okay. Oh, go to. Something is not right here. Oh, I have too many things there. All right, so I'm just going to go fix my window at this point. Instead of going -5 to 5, I'm going to actually go -5 to 7. Let's go to 8 just to make sure. If I don't make it, that's going to be super annoying, and I think I am just going to miss it. It's going to go out to 9, 10. I think I'm going to let that go because I will be able to see my intersection points on here, and then I'll just, when I do my sketch, I will graph the rest of that in there. Now there is one issue with my first intersection point. You can tell that it's at -1, 0. It's going to be very hard to actually get it to work on that one, so I'm just going to get the other two. So sometimes you may have to actually use the algebraic method to help you out. All right, so since I'm on the bottom of the bigger equation, so notice on top, mine's in blue, but notice that it's the bigger one on the bottom. So I'm going to try to get that intersection point. So I want the bottom part of that hyperbola as well. I'll hit enter. I'm still on the blue. I'm going to hit the down arrow. All right, perfect. That down arrow put me right onto the red. If it doesn't, you just have to keep hitting the same arrow either up or down until you're on the correct equation. I'll hit enter again and enter a third time. And it gives me the point 4, -3, which is a nice point. That'll be easy to remember. And I'll do it one more time. Second trace, intersect. I'm going to go hit my up arrow. So now I'm on the top part of the hyperbola, so I'm going to hit enter. I'm on the bottom of the ellipse. I'm going to hit the down arrow one more time. Now I'm on the top part of the ellipse. If you're not sure what you're on also, because you don't have the color, scroll left or right, and then you definitely can see you're on either the ellipse or hyperbola. So I'll hit enter and enter one more time. And that brings me to 4, 3. When it goes through the axis, because the ellipse and hyperbola don't, for some reason, complete themselves on the axis, that one here that -1, isn't going to work on the calculator, but we do know that that's going to be one of our points. So again, I'm going to sketch in my graph best I can. Knowing that that gets completed there. And then the hyperbola connecting right there. And here-ish. Do the best you can with your drawings. They do not have to be perfect. They just have to look like what the calculator is showing and have the intersection point. So if it's in the positive quadrant, you should have it in the positive quadrant or first quadrant, fourth quadrant, and so on. Those should be accurate, but if your picture isn't perfect, that is okay. Okay, now for algebraically, I'm just going to bring down the two equations the way they are. The annoying thing about this is it looks like eliminating the x squared would be the easiest route, except that, and it definitely would be. The problem is we have a second value of x. So for eliminating for this, we actually have to eliminate the y squareds. Because you'll notice we have that extra x in there. So you want to eliminate the variable that shows up once. In fact, I probably should underline that in a different color. Put that in green. So these are the variables that show up one time. All right, so instead, I'm going to look to multiply my equations by something that'll help me with eliminating the y's. And both 25 and 15 go into 75, so I can multiply the top equation by 3 and the bottom equation by 5. Just going to do some tiny arrows here because I don't have a lot of space. And rewrite my equations. 27x squared plus 75y squared, which will now cancel that out, minus 216x equals 243. What you'll notice here is your numbers might get a little bit large, but with elimination, things should cancel out and you should get a nice result from it. I think this one we actually do have to factor, but it's not a terrible factoring situation when we get there. So what I like to do with elimination is make sure it's something that I can add. I already had opposite signs, so that was good. We get 72x squared minus 216x equals 288. And actually, if you divide your entire equation by 72, which on the notes that I posted, I did not do that, but I should have. And this is something to look for to see if you can divide by that number in front. I end up getting x squared minus 3x equals 4. Very simple factoring, although we do have to factor. So I'll subtract the 4 from both sides to get it equal to 0. And then this factors into x minus 4 times x plus 1. You get x equals 4, or x equals -1. And then you just want to plug those in. I would pick the one that has less going on. So 9 times 4 squared minus 15y squared equals 9. Do some work to solve that out. You end up getting y is plus or minus 3. And then the other side, 9 times -1 squared minus 15y squared equals 9. You'll get y is 0. We already kind of know the solutions from previous. So we got 4, 3, 4, -3, and then -1, 0. And you do get the -1, 0 when you do it algebraically. So if you had to do that to figure that out, if you couldn't see it on the graph, you could definitely do that. Now, some of your practice, you will have just algebraic, but most of it will be a combination of graphing and then algebraic. And you can choose if you want to do elimination or substitution, whatever method seems easier for the scenario you're working with.